Here is a similar example. By the way, this one here that has a solution for unsolved problems, this is one of the problems in the assignment. You will not find the solution in the handouts that you have in Canvas, but this is one of the problems in the assignment. So this is the solution. Here I have, we have R1. This R1 has the values 1, 4, and 9. So when you turn off the switch, you have this circuit. So here you have capacitor, inductor, and you have two resistors. So the total resistance here, because we are in series in this case, will be R1 plus 6. R1 plus 6. So when you substitute in this equation, so you have to substitute by R1 plus 6. That's why I used R1 instead of R. So R1 is 1, 4, and 9, but the total resistance is R1 plus 6. So here first we need to find the initial conditions, and I have already explained this before. The initial condition for this specific problem. Okay, but for different values, or maybe I believe it is the same. The R1 was 3 ohm, I believe, but so it is the same idea. So these are the initial values, I of 0 and di of t, at t equals 0, will be like this. Then you create this table, R equal R1 plus 6, so it will be 7, 10, and 15. L is 0.5 Henry, and C is 0.02 Farad. You calculate alpha using this equation, R over 2L. And omega 0 is 1 over square root of 1 over LC. Then you compare alpha with omega 0. If it is less than, alpha is less than omega, then it is underdamped, and this is the equation. Then you just need to calculate omega d, and you know alpha already. Omega d, here, how you calculate omega d. Here it is 7.14. And if they are equal, then it will be critically damped. So this will be the equation for I of t. And if omega alpha is more than omega, then it is overdamped, then this will be the equation. Then we use these values depending on which value for R. R1 equal 1, 4, 9. Then you have different equation. So as I mentioned before, I have already prepared these equations for you, so you can just use them. So I of 0 is just A1. So for this one here, if it is underdamped, I of 0 is just A1, so it will be easy for you. For example, if I of 0 is 1 ampere, then A1 is 1. And then di by dt equal what? Equal negative 2 R1. So R1 is 1. So it will be negative 2 times R1, which is 1, will be negative 2. So here, negative 2 equal omega d. You know omega d. A2 is unknown. You need to find A2 minus alpha. We know alpha from the table. Time A1, we just calculated A1. So the only unknown here will be A2. So you need to find A2. And you do the same here if it is critically damped. But I of 0 is still A1, similar to this. But di by dt equal A2 minus alpha A1. So here you just need to substitute by A1 and find di by dt at t equals 0 from here. So it will be negative 2 times R1. R1 here is 4. And if it is overdamped, then this is the equation for the current. Here you will have two equations, two unknowns. A1 plus A2 equal I of 0, which is 1 ampere. And S1, you know S1 and S2 from the previous slide. S1 A1 plus S2 A2 equal di by dt, which is negative 2 times R1. R1 is 9, so it will be negative 18. Then in this case, you will have equation similar to this. Let us see. So, like if you have, for example, like something like this, you have A1 plus A2 equal I of 0, which is 1 ampere. 1. And S1 A1, I don't know what's S1. I don't know what's A2 S2. Let us just leave them right now like this. Equal di by dt, which is negative 2 R1. R1 is 9, so it will be negative 18. Negative 18. Let's go back to the previous slide. And then find the values for S1 and S2. S1 is negative 26.2. And S2 is negative 3.8. Then you need to solve these two equations here. You need to solve these two equations to find A1 and A2. You can solve them using any method. You can use Cramer rule. You can just multiply, for example, this one here by 3.8. Because if you do that, you have a 3.8 here as a factor. Will cancel with 3.8. So you can just multiply everything by 3.8 like this. 3.8, 3.8. And then you add. When you add, 3.8 will cancel with 3.8. And this 3.8 are negative 26. So it is 26.2. And it is negative plus 3.8 equal negative 22.4. Negative 22.4. A1 equal what? Equal negative 18 plus 3.8 will be negative 14.2. Don't have to use a calculator here. Okay. Then you divide both sides by negative 22.4. Then you can calculate A1 now. Then A1 equal what? A1 equal, first negative over negative will be positive, then it is 14.2 divided by 22.4 is this number here, 0.6, almost 4, 0.634. So it will be 0.634. So you get this one here, and you will substitute by A1 in the first equation. This equation here. So A1 is 0.634 plus A1 plus A2 equal 1. Then you can calculate A2. Very easy. Then A2 equal what? A2 equal 1 minus 0.634. That's it. 0.366. 0.366. Okay, so this will be the second value. Then in this case, you can tell, for example, what is the value here for the current equal A1. I have already A1 here. I have A1 and A2. So A1 is 0.634 times e to the power of S1. S1 is negative 26.2 plus A2 is 0.366 e to the power of what? Of negative 3.8 times t. That's it. This is the solution for this example.